Here is why faster than light travel might actually be very much possible, but we're just doing it wrong. One little thing before we get started. Please don't forget to like, share and subscribe and leave me a comment down below. Thanks very much. As I already discussed in my last video, mathematical groundwork has been done by Miguel Alcubierre and later on by the Sonny Harold G. White from NASA on actually making warp drives a reality. We know that it all works out because we know from the observation of the Hubble expansion that space-time in relation to space-time is not subject to this cosmic speed limit, the speed of light. So we know that it doesn't break the laws of known physics. The only problem is that even with smart geometrical tuning of the warp field geometry, we're still in the range of a 5-ton truck when it comes to the rest mass energy requirement to actually build a usable warp bubble around the spaceship with the size of, let's say, the Enterprise. When looking at footage released by the US Navy, however, we can observe that the spaceships they show in the infrared spectrum behave the way the Alcubierre and the Sonny White matrix actually predicts. Not only is the maneuvering pretty much the same you would expect from a ship inside a static warp bubble, but also the buildup of Hawking radiation at the edge of the event horizon of that bubble, which then ionizes the air around the ship and causes that observed plasma, is in line with what you would predict from such a geometry as described in the Alcubierre and the Sonny White field matrix. So it makes you curious whether that's maybe aliens who cracked the issue with energy. I already went down the rabbit hole in my last video, talking about gravitomagnetism and the gravitomagnetic Maxwell equations, which are also not in conflict with the current day known physics. We know that gravity waves exist, and we also know that the gravito-Lorentz force exists that has been scientifically measured. Gravitomagnetism makes the implicit prediction of materials with gravitoferromagnetic properties, which when applied, let's say used in cyclotrons like Bob Lazar described, would actually solve the energy efficiency issue when it comes to the power supply. Instead of using 5 tons of antimatter for traveling from here to Zeta Reticuli, you only would need a very small amount of antimatter for the same effect because of the increase in field strengths when generating gravitational waves in your gravitational waveguide. Bob Lazar claims that in the reactor used to power the cyclotron, which creates the gravitational waves, which then in turn polarize the hull of the spacecraft, so that at the bottom of the waveguide, the entire spaceship is the waveguide. In the bottom of the spaceship you have negative mass charge, in the top you have a positive mass charge. So Bob Lazar claims the material, the fuel used in the reactor is ununpentium, Moscovium. Moscovium, element 115, has been claimed to have been synthesized in Moscow. That's why it has been now officially called Moscovium. And multiple scientists have tried to synthesize this element by now. People cast doubt about the validity of Bob Lazar's claim that the aliens would be using ununpentium or Moscovium as a fuel, because the half-life time of Moscovium, at least the one the scientists successfully synthesized, is only a few milliseconds. However, we know that, for instance, uranium and gold also have unstable isotopes. So that's not really a argument I swallow. Just because we have not yet discovered a stable isotope of Moscovium doesn't mean there isn't one. When you look at how heavy elements are created in supernovas and hypernovas, you will realize that, for instance, uranium has many unstable isotopes. And also among the stable isotopes, only a few are really suitable for fission reactions. Like, for instance, you have to think about how you have to use centrifuge to enrich uranium. With an isotope which is even heavier, I would bet that there is even a higher amount of unusable too stable isotopes actually, and you have to use centrifugation and enrichment. Even you have to use enrichment on steroids in order to get exactly that set of isotopes you need in order to power your spacecraft. But it's not impossible that you could encounter a stable isotope of Moscovium the same way you encounter stable isotopes of uranium. It's the same thing. And gold. Just because during synthesis we encounter sometimes in super colliders unstable isotopes of gold doesn't mean gold doesn't exist. I wish gold would exist as a gold standard for the euro. Hashtag and the Fed and the ECB. Gold standard for the euro now. Gold exists clearly, but what I doubt, however, is the claim by Bob Lazar that bombarding unknown Pentium, some of its stable isotopes, with positrons would do any good. Remember that the shell of an atom is just electrons orbiting it. A positron is nothing else than the anti-electron. It's the same mass as an electron, but an opposite charge. When an electron and a positron meet, they annihilate each other, and the result is a photon. I don't think that's any good for nuclear reaction. Classically, what we know is neutrons, right? So neutrons, you have a neutron, it hits a uranium atom, and the atom divides, right? It decays. So that makes sense because you add an additional neutron and then the thing says, oh, I'm too heavy, I die. And then decays into two new atoms and releases the weak and strong forces which keep the atom together, right? Weak and strong nuclear forces. Strong force gives up, weak force, boom, right? Nuclear bombs. We all know Hiroshima, Nagasaki, right? And that makes sense, right? So the claim by Bob Lazar is that bombarding those ununpentium, Moscovium atoms with positrons would cause the formation of antimatter, which does not really make sense, right? What makes sense is neutrons, right? You have some neutron source, maybe it's like basically like uranium. It's uranium, just that its decay products are antimatter. Maybe really, maybe Moscovium ununpentium is just really uranium on steroids. That its decay products are not just plutonium, but they're actually something much more potent, right? So you give, maybe it's really like that. You have enriched ununpentium, and then the decay products are antimetal, so it's even more potent than uranium would be in a fission reactor, right? So you don't have only normal fission, as we know from a normal nuclear reactor, but you also have like pure fucking antimatter when it decays. That would be awesome. I mean, and especially if we think about it, if we really had like this ultimate cosmic Amazon delivery from some extra solar asteroid, then we would have like this ultimate energy source where you don't need like a few hundred kilograms, you only need a few grams to power a city for like a decade or two. I mean, wouldn't it be worth investigating whether we have a stable isotope of Moscovium which actually has those properties? Let's risk looking stupid and crazy. I mean, the result might be like the solution for all the energy problems in the world. Okay, enough mumbling and bumbling from old Leviathan here. However, if you encounter some mine which has iridium, please text me here, because iridium also isn't an element which naturally occurs on Earth and would have to come here through a extra solar asteroid. There is a possibility, if there is iridium, that there is also maybe Moscovium, if that would be possible. If stable Moscovium would be possible in nature during a hypernova, then there is a chance that you can find Moscovium in places on Earth where you also find iridium, because that might have piggybacked with the asteroid which also brought us the iridium. So please text me and let's get into touch and figure out how we can figure out whether there's actually stable Moscovium and whether it has actually the properties as described by Bob Lazar. Anyway, thanks for watching so far through. If you liked it, please give me a thumbs up. If you didn't like it, whoa, thanks for having me on so long. At least give me a thumbs down maybe. But anyway, thanks so much for watching. Please comment down below and don't forget to share and subscribe. See you next time. Bye.